Hi, Liang Mathematics here. This video is about standard deviation, introduction, Form 4 ungrouped data, Form 5 group data, everything about calculations of standard deviation. It's over here. Have fun. So, let the bird nest start. Okay, everybody. Today our main focus will be the calculation of standard deviation. So if you talk about variance, teacher, what's the use of variance? Basically, variance in our academic point of view, right? Okay, academic point of view, it will be more towards I get you the final answer, then you have to work backwards and find certain unknowns lah. Okay, maybe the frequency, maybe like the sum of x square, okay, sigma x square. So it's more towards to eliminate the square root. That's why there is a variance there. Okay, but never mind. If you don't understand, it's okay, because not important. Okay, it's you just treat it as they want variance, then you give it to them, but anyhow, in real life, we focus on standard deviation. So that will be the main part. Okay, now, so I'm going to move to a Form 4 related standard deviation. Okay, for you to understand the in-depth. Okay, in case you forget already, teacher, what's the standard deviation? So gone. Okay, so I'm going to show you. Come. Okay, my answer is there. Come. Don't want to show you first. For example, I'm going to take this away. Bum. Okay, so that's the standard deviation I'm going to show you. Now, everybody, it's not in your book. Okay, you can write it anywhere. Okay, on a piece of paper or maybe around the page 19 that I mentioned just now. So in this Form 4 related measures of dispersion, I repeat, measures of dispersion, same thing, right? But Form 4, it's ungrouped data. Ungrouped data basically focus on what? Okay, it focus on lesser data. Okay, where the data is more specific, a few repeated one, or maybe just a few only. Okay, so what do I mean by just a few only? Question number 3, can you see there's only 7? There's only a total frequency of 7 data. 1, 2, 3, 4, 5, 6, 7. Saw that? Or everybody, tell me in the chat, can you tell me, besides using TF, which is total frequency, any other unknowns I can use to represent total frequency? Actually, quite obvious, just in front of you. In blue color one. At the bottom. Yeah. Big capital letters are more. So which one? Like, come tell me. Yeah, correct. N. Okay, you're right. N. Okay, very good, Ying. Now, so N, TF, total frequency, right? Okay, now, so that would be what I mean by lesser data to handle, okay, in your ungrouped data. Or maybe it will be more towards repeated one. Repeated as in look at the thickness, everyone. Can you see the thickness is like 2? And can you tell me repeat how many times? You have to know the situation. That's why I'm asking you, okay? So the 2 repeated 8 times. 3 repeats like 2 times, 4 repeat 3 times. So suppose, everybody, this is 2, 2, 2, 2, 2, 2, 2, 2. Understand? And after that, it will be 3, 3. It will be 4, 4, 4. Don't write this, 5, 5, 5, 5, 5, 5, and then 6. Okay, everyone, tell me how many datas are there, or maybe total frequency, or maybe the N. How many of them? Yeah, I know, I purposely do that. Okay, Google translates. Yay. Okay, so what's that? Total frequency, how much? Or maybe N. So you just add up this thing, right? 8 to 10 already, then this one, another 10, it will be 20 lah. Correct. Okay, so everybody, this is Form 4. Okay, this is Form 4. Okay, so we're gonna straight go into the calculations. Okay, now, but of course, before we go into the calculation, tell me. Okay, I'll just focus on standard deviation. Okay, I'll just focus on standard deviation as the okay, standard deviation. Okay, everybody, standard deviation formula is given on top, but I'm gonna tell you the so-called actual formula first. What is the actual original way of understanding the standard deviation formula? Okay, so I'm gonna ask you this. No, I'm gonna say this in a very fast way where we mention it in one class. Remember this chapter, the first class itself, we talk about standard deviation. I don't know whether you still remember now. I'm gonna show you now. Ding. Everybody, still remember this or not? Remember this? I said Eddie Wu. Okay, explain the whole thing. Then suddenly I just bring. I can explain this way to the students. So that's the one. Okay, remember this. Wait, you all remember or not? You don't remember? I'm okay one. Okay, don't have to be shy. Remember this? Yes, no? Never mind, I'm here. I will just tell you. Okay, now so quick one. Okay, everybody, look at the word standard deviation. Standard deviation. Okay, deviation. Everyone tell me the word standard, what it represents. You don't go Google Translate. Oh no, Google. You search this word standard, then you get me the you get me the definition. Okay, I will slap you, serious one. Okay, so in this case, standard deviation, the word standard represents what? The red color word there. And no red color word, the red color dotted line was that. Start with M1. Yeah. Nobody put average one. Okay, a better word to it. Yes, is the mean, guys. Mean. Yeah, mean. Okay, or maybe X bar, you say it that way also can, right? So that would be the mean. So that would be the standard, everyone. So what's the meaning of deviation? Deviation basically is the word reflection. Okay, so standard deviation means from the standard itself, how far it deviates. So now you tell me the words the further you deviate, it means what? Your data is not, start with Sisihan. The further it deviates, it means the data are not, start with Sisihan. They are not, nani kore? Aina, Jinwei, start with Sisihan. Sui, start with Sisihan. Okay, I tell you all, Ashley correct. Only Ashley correct. Why? Oi, janganlah. Okay. Now I tell you, C stand for is, okay, I mentioned again. So if let's say it deviates very far from the standard mean, it means the datas are not cute. I will come and slap you. Cute. No lah. Consistent. Alamak. Kawan-kawan, consistent. Consistent. Okay, not? Okay, continue. Then how if I say the number? Constant cannot lah. Constant means a fixed figure, cannot. Okay. So if I talk about what? If let's say the standard deviations is like, it reflects like very nearly, like not that far, and so it means the data, they are consistent. But can I say the more consistent the data is, it means the situation will be very good? No. Okay, no. So that will be what we mentioned before lah. But back to the calculation, that's the main part, right? So back to the calculation, we know the formula, it will be, now wait, see, square root. Remember I put the square root thing? But before I square root, okay, I'm going to tell you this first, come. Now, so in order to get averagely, look at the word. Okay, look at my mouth here, you see. In order to get averagely, every single data reflect how much the original way of calculating it will be this way. Okay, I will just show you like fast on see. So everyone, this is the mean line, right? So how do I get the mean? Okay, I will just mention it verbally instead of writing it. So how to get the mean? Very easy. There is a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There is a total of 15 salesman, sales girl over here, total 15. So how do I get the red color sales? Red color average mean. Very simple. Just add up Bell, Brown, Cox, Edwards, Gracia, Gonzalez, Greens, everybody. You add up, divide by 15 salesperson, you will get the average line, which is 3,600. Okay, so that will be the mean. That will be the mean. So everybody, what we will do, we will take, okay, just now we have our mean. Our mean is how much? 3,600, correct? So I will take every single value. So the first value is like 3,500, correct? 3,500 compared to 3,600, it's a what? Oh, it's lesser than the standard. Can you see that? So I remember I say, I'm the manager, I slam the table. What the dude? People standard 3,600, you lesser than the standard by 100. So why you so weak? Right? Remember I said that. So the first one, it will be a negative 100. And the next one, it will be a negative how much? Alamak, negative 500. And the next one is a positive. Let's say I treat it as 3,800. It will be a positive 200. So when you get all the differences between the actual data and the mean, okay, then what you will do, everybody, you see, this is what we do, you know. So the actual value, let's say the first one, 3,500 minus 3,600, and then you get a negative 100 here, right? So we're going to add up every single data there. So this one, 3,100 minus 3,600, voila, this one, negative 500. Then the next one, it's a surplus, right? More than. So it will be 3,800. I just treat it as 3,800 minus 3,600. It's a positive 200. Everybody, I will do the rest of them. Okay, everyone, can you tell me what we will do in order to get average deviation? I have to divide how many salesperson there? 15. But the problem is, because there is a negative there, it will affect the total values, right? So I remember I said, we're going to do what? What are you going to do again? Start with S sign. In order to get rid of the negative, what we have to do? We have to, square root some more. No, we square first. We square first. We square every single data there so that it becomes positive. And then we divide by 15, get the average spread out deviation, and then we square root it so that it goes back to the original deviation. Okay, original deviation, and we will get the standard deviation. Okay, so everybody, now this is the original formula where if I come to this case, right, I'm going to quickly do it for you. See, come quick. You can write it on a piece of paper, okay? Now, but you will be able to repeat this video, everyone. Okay, we'll be able to repeat it. Okay, so now, standard deviation, standard deviation, the original way. Now, let's get the mean first. Mean 6 plus 14 plus 6 plus 20 plus 16 plus 12 plus 10. Divide by total 7 there. Everyone, quick one. How much? Calculator. 6 plus 14 plus 6 plus 20 plus 16 plus 12 plus 10. 84 divided by 7. 84 divided by 7. It's a 12. Nice. So once I get a 12, wait. Now, see, the original way. Okay, the original way. Make it smaller. Okay, now make it bigger now. Now, see, 6 is the original value, right? Then we compare to the standard. Then we laugh at the data. You 6 only. Our standard 12 is so weak. So you see, I'm minus 12. Can you see? It's a negative 6. So it means it's lesser by the standard by 6 marks. You get what I mean? Then after that, I have to add up with 14 minus 12. It's a positive 2. It means higher than the standard by 2 marks. Saw that. Then after that, the next one. 6 minus 12. And the next one, 20 minus 12, right? So that will be a positive 8 lah. So it will be like very good lah. Then it will be 16 minus 12. Okay, good. It's a positive 4 there. Very, very good. And after that, we have the next one, which is 12 minus 12, basically like break even lah. Okay, basically that's a break even there. And finally, we have our 10 minus 12 is a negative 2. Okay, everybody, can you tell me, come quick one, what we have to do first before we continue? Each and every brackets, what we have to do. Yes, very good. Very good. Good response. Nice. We have to square. Why? Why? Everyone, why? Why do we have to square? Why? Because there is negative. Yes. Okay, there is negative. We want to get rid of the negative, right? So we square it so that it becomes positive. Okay. Now, we have to divide by how much? How many data is there? So I will divide by 7 data so that I will get averagely deviates how much from the standard of 12. But don't forget, because we squared already, right? Suddenly the value becomes so big, right? So what we have to do? In order to go back to the actual spread out, okay? Spread out means like deviates how much? Yes, we have to square root. Smart, okay? So we have to square root. So that's the original way to do it, That's the original way. Of course, in the end, you will get the final answer lah. I'm not getting the final answer, okay? So I'll just leave it there. Okay, now. So what is the other way to solve it? Not to say shorter lah. It's just that we factorize it. It will be like shorter by a bit only, okay? I personally prefer the other formula, okay? But the other formula, you won't be able to understand in depth why the reason of standard deviation. That's why I insist for those that you forget about Form 4, right? You have to understand this first, or maybe our first class. Okay, so or we can use the factorized version, of standard deviation. This is the one. So that sigma x squared divided by n minus mean square. So everyone, now we're gonna do this together. This one, the one where I like it so much. Okay, now this is the one. So I'll write it in blue color. So standard deviation equals to square root. Now see, we have to minus 12 square definitely. Now everyone, divide by a total of 7, and now you're gonna do this 6 square plus 14 square plus 6 square plus 20 square plus 16 square plus 12 square plus 10 square. Everyone, this is what I mean by, can you see the negative 12, the minus 12 have been repeating. That's why you factorize out, it becomes this thing. This is not to say easier, but a quicker way to represent your standard deviation. So I will prefer everybody to do this way. Understand? Yeah, you can say factorize simpler, but understanding wise, I'm still not sure whether students understand the purpose of me getting the actual data minus mean or not. If you don't know, let me know. Okay, so original way is supposed to be every single value compared with the mean, so that we can get like averagely spread out how much. Okay, for students where you're referring to this video, right? You don't understand, just comment. Okay, because I'm going to put it in YouTube, everyone. Okay, I'm going to put it there. Okay, now, everyone, this is the so-called type 1 in your form 4. This is ungrouped. Now, let's go to the second type. Okay, second type, form 4 also. Okay, everybody. Now, wait. Okay. Yeah. Okay, okay. I scared. That's why I drag very, because when I do my that's why my class, right, it tends to be like slower. The reason being, I scared. Okay, yes, I scared. Why I scared? I scared you don't know. Okay, because like 20 plus students over here, right? The other class is like 80 plus, you know. So when I ask them, not like everybody responds. So I don't know whether you know or not. So I'll just retell you again. So that's the reason. Okay. But I admit I will be super slow. Okay. So because I've been asking students, am I super slow? They say, teacher, actually not that slow, but can be faster. I know I'm slow. Okay. Can So everyone, come. Okay, next. So over here, I'm gonna ask, you don't get it, tell me. So I'm gonna skip to what? I'm gonna skip to my, not mine, the factorized version of formula. Okay, the factorized version of formula, everyone, definitely you have to minus your mean square already. Okay, that's the mean, the mean. Okay, so why not we focus on calculation of the mean first, okay? Calculation of the mean, okay, but before that, let me ask you, can you tell me how many data is there? Actually, just now you mentioned to me already, right? So you're going to divide by how much? Divide by how much? Smart. Divide by 20. Divide by 5. Who say 5 one? Oops, never mind. I give you a chance. Divide by how many data is there? Give you a chance. Yes, smart. Okay, divide by 20. You're right. Okay, divide by 20. Because just now we have 7 data, right? So over here, how many data? 20 data. So we divide by 20. Okay, so once we get the divide by 20, everyone, the correct way to handle every single data you have to square. I repeat, you see. Now I see. Every single data you have to square. Common mistake, I tell you, everybody. Common mistake. Oh. Can you tell me what I have to place over here? I tell you the original way first. 20 data, so it means over here you have to put 20 data square, 20 data square. So meaning the right. Listen carefully. 2 square plus 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 2 square. Then plus 3 square plus 3 square plus 4 square plus 4 square plus 4 square. Lazy, you right already. 20 of them. You want me? Imagine your form 5, everybody. Form 5, I give you 40 data, how? Form 5, I give you 80 data, how? Right? Okay. Anyone? Suggest me a shortcut. Okay, come. You Liang students, sure no one. What's the shortcut? You see Sibu so smart. Ayo. Hey, I know nobody use formula, and in order to use the formula, we understand first. Umarato missed out one very important point. Jimmy missed out one thing. Specific a bit. Yeah, you see, Sui so smart. Cry not. Come tell me the figures in detail. Hey, 2 square, repeat how many times? 2 square. Tong Yang, common mistake. Okay, common mistake. Okay, everyone, see. I repeat, your 2 square repeated 8 times, repeated 8 times. Okay, student in YouTube. Okay, answer me in front of you. Pause and think. 2 square repeat 8 times, 2 square repeat 8 times. You take this answer, you times 8 lah. You get what I mean? Imagine 2 square 4 ma. 4 times 8, how much? 32 You get what I mean? 32 But the thing is, imagine if you take 8 times 2, gone. 16 16 you square it. I memorized already 256. Big difference you get what I mean? That's why you have to be careful. Okay, you square the thickness, because the thickness is the one that is the values that you want, right? Sorry, my saliva. So the 2 square, you have to times 8 times. Okay, so that will be the shortcut. So I take this away, so I'm going to take this one. Nobody write this way, okay, come on now, you in my class, nobody write this. As in, I want you to understand now. I don't want you to just memorize. Of course, others can do this also, okay? But the thing is, if you memorize, right, no point. You don't understand, right? So that's why we have to understand the reason why. So you see, I shortened already. So fun. Okay, nobody will put like super long one, right? So what happened? See, 2 square, I have to times with 8 times. And after that, 3 square, I have to times with 2 of them. Because 3 square plus 3 square, right? 3 square, 9 ma. You got 2 ma, times 2. Or you want to put 3 square plus 3 square also can, but waste your time. Okay. So next it will be 4 squared, right? Then you have to times with 3. And then your 5 squared, you have to times with 6 of them. And then 6 squared, you have to times with 1 of them. But students might ask me this, teacher, wait, I remember the square outside one, right? Got difference or not? No difference one, because anyhow you're still doing the times. If let's say the thickness that's a negative, then there will be a difference there. But the thing is, how can your x value above, you get a negative value? Impossible, right? So remember, I'm just going to remind you again, you have to square the x first, because you have to square every single data. Then after that, now the part where students, how to say, not to say you all get wrong lah. It's just that maybe you all memorize the workings, okay? Then maybe you do some common mistake, right? So everyone, I will get you like 2 minutes only. I will stop here and wait. Get me the mean for this question. I give you so many hints already. Somehow I put everything out, Get me the mean. Mean equals to what? What decimal one? Okay, now everyone, I stop you for a while. Luckily, nobody do this. Common mistakes, you all take all these things, you plus together. But I admit first, I used to do this. Yes, I heard myself. 8 plus 2 plus 3 plus 6 plus 1, divide by 5, gone, you get 4. Gone. Luckily, nobody put 4. Okay, you put 4, your level same as me. Luckily, your level is like better than me. So suppose you have to what? You see, I already put everything nicely for you, Suppose you have to 2 plus 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 every single data, divide by 20 of them. Suppose lah, but I already say nobody do that. So you have to divide by 20 for sure. So this case, you're going to do this. 2 times 8. And then 3 times 2, cry not. 4 times 3. 5 times 6. And then 6 times 1. So after you do the calculation, everything, how much you get, everybody? I do for you. Divide by 12. Okay, so what is the answer? 16, 6, 12, 30, then 6, then 70 divided by 20. Wow, smart, 3.5. Hantam the 3.5 there, then you can you can get your final answer already. Okay, everybody get the idea? Okay, can this one, Form 4 one. And now, in your mind, is like, oh, my Form 4 memories, macam get back a bit. Get back a bit really, correct? Now, go Form 5. Come, let's go Form 5. Now, so this one Form 4 version, so I go through like a quick review already, you know. Now, Form 5, ta-da, page 19 in your book. Okay, so anyone is from Mandarin class Tuesday one, right? I did question number 2. So now we're going to do question number 1. Okay, so Mandarin class, they are fast by like 3 questions. Okay, they are faster. Like last week, they do already. Okay, but it's okay. I already say, if let's say worst case, we cannot finish it, what we do? Okay, we do extra class. It's okay. And oh yeah, remind you all again. Next month, what happened? Yes, first booster class. Okay, if you interested, ask Reset. Reset will tell you. Friday, 7 to 9 p.m. 7 p.m. to 9 p.m. Friday, week 2 and week 4 only. 2 hours class. Total in the month, it will be 4 hours. Okay, come. Question number 1. Okay, page 19. For each of the distribution, calculate the variance and standard deviation. Okay, everybody, same thing. Okay, same thing. Variance, standard deviation, same one. Okay, it's just that one squared already, one not squared. Okay, so I will just focus on our standard deviation. Okay, sorry, any of it. So let's do it now. So I just put there. Standard deviation goes to square root sigma x squared divided by n minus your mean square. Okay, wait. The most important, what's it called? The most important explanation that I'm going to say it first before we start. Okay, now, everybody look at this carefully. I'm going to use red color. Now, don't you think, if yes, you let me know. If no, you also let me know. Don't you think this table is kind of similar to this table? A bit, not like exactly same. A bit. Right? Right? Not same. You tell me, okay. Okay, now I'm gonna tell you, ask you the next thing. Tell me the part where you think is not the same. You can say it's the thickness, or maybe when you go back to the case over there, right? You can say it's the length, correct? Not? But I will say it's the class, or maybe the so-called X. Okay, the so-called X. So the previous Form 4 question, can you see the thickness? Okay, the 2 is like repeated, right? The 2 repeat 8 times, correct? The 3 repeat 2 times. But over here, gone case. Because suppose this one I have to square away. How? Can you suggest me one number? Suggest me one number to replace or maybe represents 4.0 to 6.9. Use one title to represent, to take, because there's 2 numbers there, one lower limit and one upper limit. Got 2 figures, how do I square them? So what do I do? Jane, thank you. You see, I put a short form there already. M, Sinru, thank you. What is that? Start with M1. No. 4.0 and 6.9, I want to make it one number. I tell you what's it called? A quick hints, okay? Hints, you use it in frequency polygon. Yeah. Use it in frequency polygon, I'll give you another word, come. MP. MP. Yeah, midpoint. Midpoint, correct? Midpoint. Okay, everybody, see. Let's get the midpoint. Okay, let's get the midpoint. Okay, but before I get the midpoint, I'm gonna ask you, see, everybody. If you don't understand the situation, you let me know. Okay, agree or not, suppose the 4.0 up to 6.9, it will be a class where the data inside is like so spread out on. Okay, meaning what? Meaning there is 5 there, Frequency means number of, so it means most probably, I just simply hit on, okay? There will be a 4.1 there. There will be a 4.9 lah, 5.1, and then 5.3 and 6.7. This one okay, right? I mean, as in these five data happens to be in the range. Agree or not? That's why I got 5, ma. Random one. Okay, I just simply put one data there because they didn't give us. I just simply hit like some data there. So agree or not, all these 5 data fall under the fall within the 4.0 to 6.9. Try that. It falls within there. Got it? Sorry. So it means if I'm gonna do standard deviation, based on actual figure, now you see, I'll just write variance first, okay? So variance equals to this one over n, don't write, okay, like this. Then it will be over. So how many data? Tell me how many data first come. 5 plus 8 plus 11 plus 10 plus 6. How many of them? Sorry, I have to use calculator. 5, 8, 11, 10. Oops. 5, 8, 11, 10, and 6. Ding. Wow, wait. 40. A lot, 40. Then minus your mean some more. Okay, wait. So imagine if we are using actual data, gone case. 4.1 square plus 4.9 square plus 5.1 square plus 5.3 square plus 6.7 square. And then some more, if let's say over here, there is another range of number, like a lot one, like let's say I had random one, 7.2 lah, 7.4 lah, 8.1, 8.3, then a lot. So you're going to continue 7.2 square, 7.4 square, a lot. So you want to do that or not? Imagine if let's say there is 100 data, so what happened? Gone case, correct? Okay, so how? So this is what we're going to do. Okay, I take this away. That's why the reason why we design group data is to ease your calculation. Ease means simplify your calculation. The answer is still very near to what we want. Okay, like not that, I mean, as in the difference between the actual standard deviation and the estimated, because you told me that we're going to use midpoint to represent each of them. So if I use midpoint, okay, MP means midpoint. I'm going to put midpoint there, okay? So MP means midpoint. So if I use midpoint to represent 4 plus 6.9 divided by 2, 5.45, right? So it means I'm going to use 5.45 to represent this situation. So tell me, now it becomes what? It becomes the length is 5.45 already, so I will go back to something like this. So means this one is 5.45 already. So in this case, it repeat 8 times. So when I go back to this case, right, it means the 5.45 repeat 5 times. So tell me what I should write for the first working. Tell me in the chats. Because now I use 4.0 to 6.9 and I combine already. I make it a midpoint, 5.45, right? So tell me the first part, what should I do? Smart, you see. Actually, come more, I need more. More replies, like. So I write the rest of the midpoint. Tell me the first one, what you should do. 7 plus 9.9 divided by 2, you get 8.45. Then the rest, it will be plus 3 only. 11.43. 14.43, 45 plus 3, 17.45. Wow, smart. Yeah, correct. Umayrotul, and who else? Ying, yes, very good. So it means we have to take, thank you very much, 5.45. You have to square it. You put inside, outside, same one, okay? And then you times with 5 of them because it repeated 5 times. So instead of using the class of 4.0 to 6.9, wow, so many of them. So we use one figure to represent that particular class. Then the rest lah, the rest 8, then 8.45 squared. 11, 11.45 squared. And then 10, 14.45 squared. And then it will be 6 and 17.45 squared. And you will get your final answer. Everyone, sorry, I need you to really press it. For students where you're watching this video as well, spend some time pressing it. Make sure you get the actual answer. Okay, so I'm going to give you my answer in a while, but before that, there is one more common mistake as well, your mean. Okay, so we're going to make it smaller. Let's handle the mean as well. Okay, let's handle the mean. Come. Okay, so I handle the mean. So since everyone, since I already use midpoint to represent that particular class, fantastic. I know I have to divide by 40 of them already. I know that. You know that as well. So tell me, what is the first part that I should write? Come, tell me. Tell me in the chats. You're smart one, I know. Yes, very good. Okay, 5.45 times with 5 of them, 8.45 times with 8 of them, and then 11.45 times with 11 of them, 14.45 times with 10 of them, and then 17.45 times with 6 of them. So basically, it's like one estimated mean instead of saying actual mean, because we use midpoint to represent that class. Okay, so I'll give you the answer because I calculate partial of it already. It will be 470 divided by 40. And you will be getting what? 470 divided by 40, it will be 11.75. So you erase out this part, I'll make it bigger. You can replace that. Okay, this one you can replace that. 11.75 squared. Okay, now come. Pick one. Okay, really press it out. Get the final answer over here and see whether you'll get the same answer as mine or not. Just tell me in the chat your final answer. Can already. Your variance. Standard deviation, let me do. We're going to square root the answer later. The answer is around one slice of secret recipe cake. Yiling correct. Around there. One slice of secret recipe cake, how much? Sui also correct. Around 10 plus, $10 plus minus, correct? Around there, your answer is around there. Never mind, I check prep. I check for you. Come you all do, How much is one slice of secret recipe cake? Yame 6, no lah. No lah. Where got so cheap one? Hey, got a Jinwei. If let's say premium type one, premium type 11 ringgit 80 cents. But now I don't really go out, so I have to plus delivery some more there around there. Like the normal type of cakes like 9 ringgit 81 cents. Plus delivery then gone. Okay. So everyone, stop. The answer is 13.86. Then you divide by 13. You square root 13.86. How much you get? 3.723. That's the answer. Okay, so for everybody, I want you to try it up all these questions. Okay, here. Number 2, can you write down the answer so that you all can try it up? Okay, just to practice. Okay, see whether you can get the actual answer by attempting. You attempt it yourself. So see whether you can get the answer or not. So number 2, that's the answer there. But Mandarin class student, they go through this question already. So anyone replace from there, you all know already. Okay, take down now. Okay, number 3, come. Number 3, the answer is here. Nice.